I keep telling people that AI agent that writes code is mostly a marketing phrase. Then Google DeepMind shipped AlphaEvolve, and I have to caveat that. The interesting part isn't that it writes code, it's that the code it writes is going into actual TPUs. Quick framing. AlphaEvolve is a Gemini-powered coding agent from Google DeepMind, and the way it works is closer to evolutionary search than to a chatbot. You give it a problem with a measurable score, latency, footprint, accuracy, whatever, and it generates candidate programs, evaluates them, keeps the winners, mutates them, and grinds. We've seen this shape before. AlphaCode did competitive programming. FunSearch found new combinatorial constructions. AlphaEvolve is the version that's been pointed at production systems instead of benchmarks. And the results Google just published are the reason this story is worth 8 minutes of your time, not 8 seconds of a feed scroll. Start with the headline result, because it's the one that made me sit up. AlphaEvolve proposed a circuit design that was integrated directly into the silicon of Google's next generation TPUs. Read that again. A model suggested a hardware circuit, humans reviewed it, and it shipped into a chip mask. That's not autocomplete. That's a Gemini-driven search loop producing artifacts that survive a TPU design review, which is one of the more adversarial engineering processes on the planet. Worth knowing, we don't know which block, we don't know how big the win was, and integrated directly into the silicon is doing a lot of work in that sentence. But the claim itself, from DeepMind's own post, is specific enough to be falsifiable, not a small thing. Now the systems wins, because these are the ones engineers in the audience can actually map to their own work. First, Google Spanner. AlphaEvolve reduced write amplification in Spanner's LSM tree compaction heuristics by 20%. If you've ever tuned RocksDB or Cassandra, you know why that matters. Compaction is the thing that quietly eats your I/O budget, and a 20% reduction in write amplification at Spanner scale is an enormous amount of disk that no longer gets rewritten. Second, compiler optimization. AlphaEvolve produced strategies that cut the storage footprint of software by nearly 9% across a Google-sized binary fleet that compounds. These aren't novel algorithm on a whiteboard results. These are heuristic tuning problems where the search space is huge, the objective is clean, and a tireless evolutionary loop is exactly the right tool. Then it gets more interesting because Google let outside teams point AlphaEvolve at their own problems. Klarna used it to optimize a transformer model and doubled its training speed while improving model quality. Both access at once is the surprising part. Usually you trade one for the other. Schrödinger, the computational chemistry company, used AlphaEvolve on machine-learned force fields, MLFFs, the things that approximate quantum mechanics for drug discovery simulations. Roughly a 4-time speed up in both training and inference. That's the kind of number that changes which experiments are even worth running. And WPP, the advertising holding company, reported a 10% accuracy gain on top of their existing competitive manually tuned model optimizations. 10% over a strong human baseline is the harder bar. Different industries, same pattern, existing pipeline, well-defined metric, AlphaEvolve grinds out a better configuration than the humans had found. Here's the catch, and there's always a catch. Every result I just listed has a precise machine checkable score function. Compaction right, amplification, binary size, training tokens per second, force field accuracy on a held out set. Evolutionary search is brilliant when you can grade 10,000 candidates automatically. It is much less brilliant when good is a judgment call. Most of the code your team writes does not live in that regime. Make the service maintainable is not a fitness function. Don't break the customer's trust is not a fitness function. So when you read the AlphaEvolve post, separate the headline, coding agent improves code, from the actual mechanism. which is automated search over a measurable objective. I'd say this is genuinely useful for a specific class of problem. I don't buy the framing that it generalizes to all software work. Not yet. Stepping back for a second, this is the third thread this year pointing the same direction. AlphaEvolve on TPU circuits and Spanner, Sakana's AI scientist generating ML research artifacts, the various code evolution agents from smaller labs. The pattern isn't AI replaces engineers. The pattern is that any pipeline with a clean metric and a big search space is now a candidate for being handed to a search loop with an LLM in it. For people building with AI, that reframes a real question. Where in your stack is there a knob you've never had time to tune properly? A heuristic somebody set in 2021 and nobody's touched? A model config that's good enough? Those are the AlphaEvolve shaped holes in your code base, and the tooling for filling them is going to keep getting cheaper. The concrete thing to do this week: pick one component in your system where you have an automated benchmark and a clearly defined score. Just one. Write down what the current best configuration is, who picked it, and when. That document is the input you'll need the day an AlphaEvolve style tool is sitting in front of you. The bottleneck won't be the model, it'll be knowing what to point it at. That's what I've got on AlphaEvolve. If you've already tried something like this on your own systems, tell me in the comments. I'm collecting examples for a follow-up. See you in the next one.